All right, so good afternoon again, everybody. Today is January the 14th, 2022, and today we're going to start looking at the quadratic graph. So here's how I would start out. I would start out by saying that y is equal to ax squared plus bx plus c is the general format of a quadratic equation or a quadratic function. Then I would say that the graph of a quadratic function is a smooth curve called a parabola. So we already learned about the straight line graph. And for the general format of a linear equation is y is equal to mx plus c, where m is the gradient and c is the y-intercept. So if I draw a graph of an equation of that form, I would get a straight line. But if I draw a graph of this form, of an equation of this form, if I draw a graph of an equation of this form, this equation is a quadratic equation, and the graph of a quadratic equation is a smooth curve that is called a parabola. Guys, a parabola could look like this. And when the parabola look like that, we say that the parabola is a frown, and the parabola could look like this. When the parabola looks like that, we say that the parabola is a smile. So your parabola could be a smile or it could be a frown. The determining factor is the sign of the number in front of x squared. If the sign of the number in front of x squared is positive, you get a smile. So this is when you have a positive x squared coefficient. So if you have a positive x squared coefficient, you get a smile. And if you have a negative x squared coefficient, you get a frown. So we're going to get into all of that and you're going to see it in action. All right, so this is what a positive x squared graph, or the graph of a positive x squared quadratic equation looks like. So this is when the number in front of x squared is positive. When the number in front of x squared is positive, you're going to get the smile. All right, so that's what a parabola looks like. A little piece of it was not drawn, and that can happen. So this shape is what you call a parabola. Let's have a look at the features of the parabola before we actually draw one. So first of all, this is what the graph of an equation of the form y is equal to ax squared plus bx plus c would look like. If I draw a graph of an equation of the form y is equal to ax squared plus bx plus c, the graph would look something like this, and this shape is called a parabola. Now, the first thing about this, the first feature of this graph is this: a, which is the x squared coefficient, is positive. So this could be something like this: y is equal to, let us say, 2x squared plus 3x plus 2. Or in this case, minus 2. All right, so the graph could look something like this. The graph of that equation that I just write could look something like this. And the first thing you need to note is that the number in front of x squared is positive. If the number in front of x squared is positive, you're going to get a smile. If the number in front of x squared is negative, you will get a frown. Stay with me. So that's the first feature. The second feature is this: y is equal to q is the minimum value of y is equal to ax squared plus bx plus c. Guys, every point on your graph has a value of what? Every point on your graph has a coordinate. And a coordinate have what? X value and a y value. You always have an x coordinate and a y coordinate. All right. Now, at the lowest point on your graph is at the lowest point on your graph, that is when you're going to where you're going to find the minimum value of y. This point is the lowest point on the graph. It's actually called the minimum turning point. And it is at that point you're going to get the lowest value of y. Guys, if I draw a horizontal line at that point, it cuts the y-axis at Q. So that horizontal line would be the line y is equal to Q. So y is equal to Q is the minimum value of y is equal to ax squared plus bx plus c. Guys, we're talking about things in general, but if when you're doing this question, you're asked for the minimum value of y, you'll find the minimum value of y at the lowest point of your graph. Guys, remember I said at every point you have an x value and you have a y value. The vertical line that passes through this lowest point cuts the x-axis at P. So this is the line x is equal to P. So at the lowest point on the graph where y is equal to Q, x is equal to P. So point 3 is saying x is equal to P is the value of x for which y is a minimum. So the value of x that makes y a minimum is x is equal to P. All right, guys, remember, if I have this equation here, y is equal to ax squared plus bx plus c. When I put in different values of x, I'll get different values of y, don't it? But if I put in x is equal to P, that is when I will get the lowest value of y. So x is equal to P is the value of x at the point on the graph where y is a minimum. Guys, all of this thing, you will see the practicality of it in a couple minutes. Guys, the vertical line that passes through the turning point is called the line of symmetry. You will see that definition on the next page. The vertical line that passes through the turning point. Now, the vertical line is passing through the turning point is x is equal to P. So x is equal to P is the equation of the line of symmetry. Guys, the turning point. The vertical line through the turning point is x is equal to P. The horizontal line to the turning point is y is equal to Q. It means, therefore, that P, Q are the coordinates of the minimum turning point. Guys, the C in the equation y is equal to ax squared plus bx plus c. The C is the y-intercept. Just like from y is equal to mx plus c, the same thing here. C, the constant term in the equation, is the y-intercept. And because the y-intercept is on the y-axis, 0, c are the coordinates of the y-intercept. Stay with me. These values here, they're called the roots. And since the roots are the values of x, where the graph cuts the x-axis, the roots are called the x-intercepts. So turning the page. So x is equal to alpha and x is equal to beta. Beta are the roots of y is equal to ax squared plus bx plus c. X is equal to alpha and x is equal to beta are called the x-intercept. Guys, earlier I talked to you about the line of symmetry. So we have a graph looking like this. We have a graph looking something like this. This is the lowest point, the minimum turning point. The vertical line that passed through it, this line is called the line or axis of symmetry. It's called the line or the axis of symmetry. So the line or axis of symmetry is a vertical line that passes through the turning point. All right. Now, the roots of the function y is equal to ax squared plus bx plus c are the values of x for which ax squared plus bx plus c are equal to 0. So if you solve the equation ax squared plus bx plus c is equal to 0, the values of x you get when you solve this equation, so the values of x are the roots. So the solution are the roots of ax of y is equal to ax squared plus bx plus c. So the roots of the quadratic function y is equal to ax squared plus bx plus c are the values of x for which ax squared plus bx plus c is equal to 0. And you're going to see the practicality of that in action. On the graph of y is equal to ax squared plus bx plus c, the roots are the values of x where the graph cuts the x-axis and where the graph cuts the x-axis. Those values of x are called the x-intercepts.